In 7.2, we're going to be looking at what are called oxidation numbers. So first of all, when we have been looking at ionic charges, we're looking at ionic bonds. So the transfer of electrons causing either positive charges or negative. Now with oxidation numbers, we are looking at molecular compounds where they're sharing the electrons, but they're pulled slightly to one side or the other. And this is going to be for molecular compounds or when polyatomic ions are formed. So we have to determine the oxidation numbers for each element in a compound. And so we have to figure out how we're going to do that. First of all, we're going to assume that the shared electrons are going to be pulled towards the more electronegative atom. And this is something we discussed in chapter 6. Rule number 1, when we have atoms that are of pure elements or they're not combined with another type of element, the oxidation number is always 0. So if we look, for example, sodium, if we ask what's the oxidation number of just sodium or just oxygen or just fluorine by themselves, not combined with anything else, the oxidation number is going to be 0. Number 2, if we have a binary molecular compound, which means we have 2 elements in that molecular compound, the more electronegative element is going to be the charge of that if it were an anion. The less electronegative will be the charge if it were a cation. And if you remember, the less electronegative element is always named first. So that is going to be your cation or your positive. And the more electronegative will be the anion or the negative. So we can kind of assign those just as if they were charges. F is always going to be -1 when we have a compound. If F is just by itself, it's going to be 0. But when fluorine is in a compound, its oxidation number will always be -1. And these next 3 rules are something that you might want to write down because these are going to be things that you're going to need to memorize. Oxygen is almost always going to be -2. If it's a peroxide like hydrogen peroxide, it will be -1. If it's with a halogen, something in group 17, oxygen is +2. But almost all of our circumstances, it will be -2 in a compound. Hydrogen in a compound is almost always going to be +1, unless it's with a metal, and then it will be -1. But again, for most of our problems, it's going to be +1. The sum of all the oxidation numbers in a neutral compound is going to be 0. If we're trying to find the oxidation numbers of a polyatomic ion, then the oxidation numbers are going to add up to be the charge of that ion. And we'll look at what all this means in a minute. So here are some examples. We have our first one is PCl3. So we want to determine what's the oxidation number for each individual element. So for phosphorus, for each chlorine. So the first thing we need to decide, is this a compound or is this a polyatomic ion? And since we don't see a charge, this is a compound, so the oxidation numbers have to add up to 0. So the first thing that I always do is I split this in half. One side is going to be negative, the other side is going to be positive because we're going to total these up to equal 0. Chlorine, if I look at the charge of chlorine, that's going to help me figure out the oxidation number. So each individual chlorine has a -1 charge, so a negative oxidation number, but we have 3 of those to give me a total of -3 on the chlorine side. So if the whole thing has to add to 0, if this side is -3, then this side has to add up to +3. So my answer for each individual phosphorus is +3. For each individual chlorine is -1. So that would be my answer to the oxidation numbers of PCl3. Let's look at the next one. If I look at CS2, I'm going to split it in half. S, the charge is -2. So each S is -2, but I have two of those. So -2 times 2 means this side is going to total up to -4. So since this side and over here for carbon have to be 0, then the carbon has to be +4. So my answers for oxidation numbers here will be carbon is +4, each sulfur is -2. Pi3, each I is -1, but we have 3 of those. So if this side is -3, phosphorus has to be +3. So my answers here are phosphorus is +3, iodine, each individual iodine is -1. Let's look at a few more. We have UF6. First of all, we said that F always has to be -1. So -1, but we have 6 of those. So that side is -6, which means U has to be +6. Now the next one, we have 3 elements involved. So it's going to be a little bit different and a little bit more complicated. So first of all, I have to determine where is my polyatomic ion. So that's going to be the SO4. So I'm going to make my split there. Then I need to determine what is the charge of that ion. So if I use my polyatomic chart and I look up SO4, it tells me that that has a -2 charge. At this point, I need to have this side and this side add up to 0 because the whole compound does not have a charge. However, SO4 has a charge of -2. So when I split SO4, and I'm not going to work with the hydrogen yet, when I split SO4 into 2 sides, they're going to total the -2. So if I look at oxygen, we said oxygen is -2, but we have 4 of those. So this side is -8, which means my sulfur, to get these 2 sides to be -2, sulfur has to be +6. So that -8 and +6 give me the -2. Now, if this whole side is -2, that means the hydrogen side has to total up to +2. But we have 2 hydrogens. So +2 divided by how many we have, which is 2, tells me that each hydrogen is +1. And we know that hydrogens are usually supposed to be +1, so we could have worked this a little bit different to determine that. So my answers are going to be hydrogen is +1, sulfur is +6, and each oxygen is -2. We'll work a couple more of those just to kind of get you familiar with some of those polyatomics. Let's look at water. Now water, we can do a couple different ways because we know that oxygens are supposed to always be -2, We know that hydrogens are always supposed to be +1, and we have 2 of those, so that makes this side +2, canceling out my -2 to give me a total of 0. So my answer is +1 for hydrogen, -2 for oxygen. Before we go further, I'm going to do another one that has a polyatomic in there. So let's try, let's say, let's do Na. Let's try a different one. CO3. Okay, so Na2CO3, my polyatomic is the CO3. So I'm going to go ahead and split that right there. So these two sides have to add up to 0. The polyatomic, this C and O3, have to add up to the charge. And if you look at your polyatomic chart, the charge of CO3 is -2. So these two sides have to add up to -2. Before I work with CO3, if I know that this side is -2, this side has to be a total of +2 to get my 0. So this side is +2, each sodium is going to be +1. So I've got that side done. So let's come back to the CO3. We know that oxygens have to be -2 from our rules, but we have 3 of those, so that means this side is -6 if we multiply the 3 and the -2 together. So if -6 has to add with whatever is over here to get -2, that means carbon is going to be +4. So my answers would be sodium is +1, carbon is +4, and each oxygen is -2. Now we're going to look at how do we name these. So we're going to use the stock system, which means we're going to use Roman numerals. And our Roman numerals here are going to indicate our oxidation numbers. The first element will have the Roman numerals to indicate the oxidation number, and the second element is going to end in IDE, and it won't have Roman numerals. We are not using prefixes. So these molecular compounds, you can name them 2 different ways. You can name them with prefixes, or you can use Roman numerals and indicate their oxidation number. So the first thing we have to do is determine the oxidation numbers. So Ci4, I is -1 from the chart because it's in group 17. We've got 4 of those. So that means chlorine is going to have to be +4, so these add up to 0. So this is going to be carbon 4 iodide. If we look at the next one, SO3, our rules say that oxygen is going to be -2. We have 3, so that gives me -6 for my total there. So sulfur has to be +6. So my name for this would be sulfur 6 oxide. The last one, we've got As2S. Sulfur is -2, and there are 3 of those, so that's -6. So this side has to be a total of +6. So we're going to divide that by 2 because we have 2 of those. So each As is going to be +3. So this is going to be arsenic 3 chloride. I'm sorry, it should be sulfide, not chloride. Sulfide. And that is 7,2.